Okay, so let's go on turn to number 2 in your release package. You know, the thing about these release packages that once they've got a released version of the test, and they changed the SOL about 2012, so this comes after that. They don't change it a lot year to year after that. So these 50 questions are probably pretty close to the 50 questions you're going to get. That's why we're using this as a guide. So first strategy to solve this problem is, you know, if you're adding complex numbers, then you need to add the real parts and add the imaginary parts. But remember, you can put it in the calculator, right? There's an I character on the decimal point. You can enter it in exactly like you see it there, and it'll do all the math for you. Okay? So either number 1, I'll show this if you want to get out your calculator and try it. Plus 5i minus 11 minus 13i. And then there's our minus 17. And so it's minus 14. It's minus 9i. So either you add the real parts and add the imaginary parts, or you put it in the calculator using, I'm going to clear my memory. Using the I character. So parentheses, negative 6 minus second I, parentheses, plus 5 second I, minus parentheses, 11 plus 13 I. So when you're happy you've got it in there correctly, then you enter it. Yeah. So the right answer here was letter A. Got it? Take a note on it. Can help you. Okay, number 11. I'm going through them in order, not like by topic. So just these are going to be 25 questions in some particular order. So this is the properties question from this test. And we talked about this when we went over the homework. Which one of those is an example of symmetric property?
Oh, you flip them, don't you?
So which one would look like that, William?
Okay, if that's no, this is really. Oh, wait a minute. Okay, I think it'll be B.
B, right?
Yeah.
If all you're doing is changing the sides that they're on, that's symmetric property. So no tricks for that one. You just kind of have to know these properties. Okay, identify each expression that's equivalent to I. So there's 4 powers of I there, right? Remember, there's a pattern to the powers of I. And they start with I to the first, which is obviously equal to I squared, which is equal to what? -1 by definition. I to the third, which should be I squared times I, negative I. And I to the fourth is 1. So if I start over at I to the fifth, it'll just be I again, and then I to the 6th will be -1, and I to the 7th will be negative I, and I to the 8th will be 1. So basically every power of 4 exponent of I is going to be 1. Every even power, which is not a multiple of 4, is -1. Every multiple of 4 plus 1 is I, and every multiple of 4 minus 1 is negative I. We want all of these numbers that are multiples of 4 plus 1. So is 47 a multiple of 4 plus 1? No.
Well, plus 1 that'd be 48. No.
So how about I to the 33rd?
Yes. Yes.
Yes, so definitely that one. How about I to the 21?
Si, senor.
Yeah, because 20 is a multiple of 4. And I to the 15?
No.
No. Now remember, you can put these in the calculator, right? Because you got that I character. But remember this thing, that sometimes you'll get some funny characters when you do this. So let's say I try I to the 33rd just to show that it works. I to the 33rd, and it gives me some scientific notation, which you may find confusing. In the end, that scientific notation is really just 0. It's -3 times 10 to the -13th, and the calculator just hasn't rounded it to 0. But if you don't want to see that, then you do it like this. You go math, num, number 3 is I part. And then put the calculation in there. So second I raised to the 33. And end parenthesis. And then it won't give you that scientific notation, which is supposed to be 0, if it matters. Next, number 16. Solving a quadratic equation. And it's not a multiple choice. Well, it kind of is a multiple choice. What do I have to do to this thing before I apply some method?
Solve.
You need everything on one side. Standard form equals 0.
Right.
So let me write this as x squared plus 4x minus 16 equals 0. Okay. Then what? I mean, my first question would be, is it factorable? Are there factors of -16 that add up to 4?
No.
And there's not. So scrap that. Okay. So what's the other option?
Quadratic.
Quadratic formula will always work, and that's given to you on the test. So you can -b plus or minus. It's also the, oh, you don't have that yet. Sorry. I'll write it down here. -b plus or minus the square root of b squared minus 4ac divided by 2a. So -4 plus or minus the square root of 4 squared minus 4 times 1 times -16
Over 280.
over 2a.
280.
2 times 1. So that's -4 plus or minus the square root 16 plus 64, which is 80, divided by 2. So before I go any further, look at the 5 choices there. It's clearly not going to end up to be plus or minus 4. Scrap that. The square root of 80 is going to be a real number, not an imaginary number, so get rid of the ones that are I. And now, the only difference between the last two is whether or not that first number is going to be positive or negative. And you should be able to tell just by what you've done so far.
Negative.
-4 over +2 is going to be -2. That's all you have to do. Now, do you remember when we solved systems of equations? Remember, you would put one equation on line 1 and put one on line 2, and then you'd say, second trace 5, enter, enter, enter. Well, you can solve this one that way too. Right? You could put the left-hand side of that equation, x squared, on the first line, and put 16 minus 4x on the second, and then look for where they intersect. And it actually works pretty well. I did this one just to make sure that it works. So if I put x squared on this line, and enter, and then I'll put 16 minus 4x here, and I want to see where do they intersect. Second trace 5. Let it draw the graph. Okay, and you could definitely see this one intersection point. And the other one is off the screen, but we should be able to tell by that one intersection point. Second trace 5. Enter, enter, enter. And it looks like it's 2.47 is the x value. So you know, if you go through here and try to figure out which one of the, just try to turn these into their decimal values, you'd pick the one that was. So I would imagine with most of you guys, you don't need that kind of a trick. Well, but you do have to do systems of equations eventually. So I want, you know, let's not forget how to do that. Oops. So let's go to number 18. This is like the homework from last night. First step, isolate. Done. Right? Second step, break it down. Remember, how did we do less than? Right, so you would solve negative 2 is less than x plus 4 is less than 2. So isolate the x in the middle now. Subtract 4. Negative 6 is less than x is less than negative 2. Now remember that there's also a way to do this in the calculator. If you go to y equals, clear, right? And obviously in this expression there is no y, okay? There is none, but don't worry about it. Just put that inequality to the right of the equal sign. All right, this is how it works. First, where do you find absolute value? Right, absolute value is at math num 1. Math num 1. Or you can do alpha window 1. Either one of them will bring it up. Okay, so math num 1. And I'm going to put in my x plus 4. And I got a right arrow to get out of that. Okay, now you need the inequality symbols, right? Second math, the test menu. Second math. And pick out your symbol. We needed the less than, which is number 5, and less than 2. Okay, now hit graph. You see it graphs it for you. Now, could you tell from looking at that graph that it's between negative 6 and negative 2?
Yeah.
Okay, there you go. So if you put it in the calculator, it'll graph it for you. You'll get the answer that way. So the inequality symbols are at second math. Good to go? Let's go. Next, which appears to be the solution of g of x equals 0? So let's say that's the function y equals g of x. But where on that graph does a function equal 0? It's the x-intercepts, right? Remember, on the x-axis, y equals 0. So actually, all it's asking you for here is what are the x-intercepts? And the x-intercepts are clearly negative 3 and positive 1, only one of which is in that list. So you say A. That was number 19. You okay, Ken? We ready? Okay. All right. 20. What are the x values for the solutions to this system of equations? Okay, so solving a system of equations, which methods did we have? Substitution, elimination, or you could graph them. right? Any one of those here. Any method you think would be easiest just looking at this? You know, honestly, when I looked at this thing right away, I noticed that there's only one y in each equation. It's just one y to the first in each one, which means if I subtract these equations, I've just eliminated a variable. To me, I would have thought of that. And I'm going to subtract the second one minus the first, so I keep the x squared positive. So x squared minus all of this. So it'll be x squared minus x. The y's cancel. Negative 2 minus 10 is negative 12. So you have to solve that for x. And that's a fairly easy factoring problem, right?
Mm-hmm.
Right, that would have been x minus 4 times x plus 3. So x equals 4 or negative 3. Now, if we graph them, first you have to solve for y. So the first one would have been y equals negative x minus 10. The second one would have been negative x squared plus 2. So again, you could put that in the calculator. Y equals negative x minus 10 and negative x squared plus 2. Right? And if I look at the graph, just to see what it looks like, you know, you could see one intersection point and you don't see the other. But let's find the one on the screen. Second, trace 5, enter, enter, enter. And it was negative 3. Okay, now, looking at our options there, 2 of them had negative 3, right? But it's pretty clear looking at the graph which one of those has got to be the right one, right? Because it's going to be intersecting to the right of the y-axis. It's got to be a positive value for the other x. I don't really need to check. It's not negative 7. That would be somewhere over here. So the answer is this. Second, trace 5, enter. Okay, next. 22. So here is a graph of a system of equations. Okay, what are the apparent solutions? And this is given as a technology enhanced, not a multiple choice. You're supposed to use the cursor and click on the solutions. How many solutions do you see?
2.
Okay. So one of them is here, and one of them is here. Click, click, done. I'm sure there'll be one like that. It's that easy, you know. You just look at the graph if you know. Just don't start picking x-intercepts, right? That's when you have like one equation, not 2. When you have 2 equations, it's the intersection points. That was 22. 24. An absolute value equation. Which again, you could, to solve it, first we have to isolate, right? This is the actual math.
Mm-hmm.
And then you have to write 2 equations. What are those 2 equations going to be?
Broken down equation. Right.
2x minus 7 equals 8. 2x minus 7 equals negative 8. Solve. 2x equals 15. X equals 15 halves. 2x equals negative 1. X equals negative 1 half. So the answer was this. So what other kind of strategies could you have used to solve that?
Calculator, right?
You could have just plugged in the 4 answers to see which one works. You know, I mean, that's always an option when you're solving an equation. Or you could have done a system of equations. Make the left side line 1, make the right side line 2, and just look for the intersection points. Okay? So, or back substitute. Or solve as a system. Okay, next. 26. This is one that I would guess that you might have a little, don't remember much about it. I think we probably did it, or something like it, but if we didn't, it'll just have to be now. Okay, a solution to a quadratic equation is 13 minus 11i times the square root of 7. Which of the following must always, must also be a solution to this equation? So what are you going to say? D, because why?
Plus negative sign, right?
Conjugates, right? If you ever get one irrational or imaginary solution, you have to have the conjugate, right? Because where do these solutions come from? When you see a square root as a solution to a quadratic, it must have come from the quadratic formula. And what's in front of the quadratic formula? Plus or minus. So you're never just going to get one of them. You're always going to get both. So if there's 13 minus 11i root 7, there's got to be 13 plus, right? Those are conjugates. So just remember that irrational, which is the square root of 7, or imaginary, complex, solutions occur in conjugate pairs. You know, it's more of a knowledge question. But if you know it, I mean, it's 2 seconds, not even half a second. Click, done. Move on to the next. 27. Which of the following functions does not have a range of only the real numbers greater than or equal to 0? So how are you supposed to tell that? And you could graph them and look one at a time. You should know by just knowledge of the function a little bit. You know, the first one is a radical, right? So basically, the parent function for the original, for the square root of 4 minus x, the square root of x looks like this. It starts at 0, 0, and it goes up from there. That would have a range of greater than or equal to 0. So the only question is, by making it 4 minus x, what kind of a shift is that going to be? Is it going to move it up or down? Because that would change the range. And the answer is no. You go up or down by adding after the function. So that one's still got a range of y greater than or equal to 0. What about the graph of an absolute value? What does it look like? An absolute value is a v, which has the vertex at the origin, so it has a range of y greater than or equal to 0. Is subtracting 4 inside going to move it up or down? No. Right? How about x to the 4th? You know, you probably don't know what that shape might look like, and you could just put it in the calculator, right? If you look at it, it looks like y equals clear. Because we know if it's an x to the 4th, it could have 3 turning points in it. But actually, x to the 4th does not. It could have, but it doesn't have to.
It looks like parabola.
Yeah, it more or less just looks like a parabola. I mean, your only question would be, is 0, 0 going to be on that? Is it greater than or equal to? And 0, 0 is on. You can plug in 0 and you'll get 0. So this one is checked. That's good. But that brings down to logarithm, right? And a logarithm looks like this. And what is the range of a logarithm? All real numbers. Its domain is x greater than 0. The range is up vertically, right? It's all up and down. Now, I want to see what that looks like in the calculator, because you might be deceived by this. Clear. So there's the log button. What's the base of the logarithm if it just says log? It's base 10, right? And now when I hit the graph, I mean, it's kind of hard to see what's going on there, but it clearly doesn't look like it's going along the x-axis, you know, infinitely. It looks like it just cut off. So please don't think that means that the graph actually cuts off, because it doesn't. And even if you zoomed in, zoom 2, you would for sure see that it goes below the x equals 0 or y equals 0. So the right answer was this one. Again, if you have a good knowledge of the functions and what they look like, that's really all they were asking you to do, is just recognize the functions. Because the logarithm was obviously the one to pick. Okay, what is the sum of this infinite series? Okay. So let me pause for a second. Okay. So look on the inside cover. If you have to find the sum of an infinite series, which is the only formula there that would do that for us? There's only one that's got an infinity subscript on it, right? Yeah, it's this one right here. The sum infinity of A1 over 1 minus R. Right, so the A1 is, what does A1 refer to? The first term, right? So the A1 is the 100. And what is R?
It's the radius.
Right?
It's the thing you multiply the terms by to get the next term.
Yes, which means it's the ratio of consecutive terms, the common ratio. So like if I take the second term, 60, and divide it by the first term, 100, that's the common ratio. So, I mean, you could write it as 0.6, 3/5, whatever you want. How about I'm just going to say 0.6. And then just plug it in. S infinity equals 100 divided by 1 minus 0.6. 100 divided by 0.4. Right, which is what? $250.
Oh yeah.
I mean, it's 1,000 divided by 4, so it's 250. So 250. So sequence and series, you need to you need the formulas. Just know where these formulas are. Hopefully you know how to use them if you get them. Okay, the heights of a large population of, this is 37. The heights of a large population of ostriches are normally distributed. Which is closest to the percentage of these ostriches that is within 3 standard deviations of the mean? Yeah, we just did it in the homework, or in the most missed questions. Okay, quiet, please. Laura, you paying attention to this? Are you turning this page? Okay. So, what's the percent that are what's the percent within 3 standard deviations?
I think that's 95. But apparently that's 60.
Well, remember how, if you don't remember these percentages, remember you could have the calculator do it for you. Remember, if you go to the normal, remember normal is at second vars 2, and Why is that doing that? Clear, clear. Second bars 2. There we go. If I want to go within 3 standard deviations, then say that the lower is -3 and the upper is 3 and the mean is 0 and the standard deviation is 1. That's called the standard normal curve. And then that'll tell you the percentage within 3. 90.997, 99.7, right?
Right.
If you want to do between 2 standard deviations, then do -2 to 2, right? So if you don't remember these, you can always figure them out with the calculator. But it's 68, 95, 99.7. Okay. And that's just, it's a memory thing. They didn't even give us a mean or standard deviation to deal with, so. I think I'm going to do 3 more and then the rest we'll save. 38. Which of these situations involves a combination? Okay. If it's not a combination, what would it likely be? We're usually choosing between 2 kinds, right? Combination or permutation, right? And what would make you think it's a permutation if order is important, right? So they're saying one of these here, order is not important.
Okay.
Right, you're just choosing a certain number of positions from a larger group. Right, remember it looks like this, NCR. And we're not even having to do the math. Determine how many different groups of 3 employees can be chosen from 10 employees. Yeah, that sounds like a combination to me, but I would probably read the next 3 just to be sure, Determining how many different seating charts can be made by placing 7 people around a table. No, because then it's order. I mean, your seating chart, everything's about order. So, not determining how many different ways 8 runners can be assigned in lanes on a track for a preliminary race. No. Remember, for B and C, that's a factorial problem. 7 factorial, 8 factorial. That's how you figure that out. Or determine how many different 6-letter passwords can be made by using the letters in the word pencil. Right? Definitely order is important. Because all you're doing is rearranging 6 letters. So the right answer was what we thought at the beginning. Right? Order not important. Order not important. Okay. 39. What is the 14th term of an arithmetic sequence that has a first term of 7 and a common difference of 10? Okay. Go back to the formulas on the inside cover there. Which formula would we need for that? The first one, right? In the arithmetic column, the nth term of a sequence equals the first term plus n minus 1 times the common difference. So they actually already gave us the first term and the common difference. So you can plug that in. An equals 7 plus n minus 1 times 10. And they didn't ask you for a formula, so we don't really have to simplify. If you want to find the 14th term, then plug in n equals 14. A14 equals 7 plus 14 minus 1 times 10. A14 equals 7 plus 130, which is 137. How else could you do that? You could just keep adding 10, just write them out, The brute force method, and this one really wouldn't be that hard. So the last one. The graph of a function is shown. That's this, right? Which of the 4 options is the inverse? What do you know about the coordinates of a function and its inverse? They have the x and the y flipped, right? So take a couple points on this function. Let's say the x-intercept is 4, 0, and the y-intercept is 0, 2. So on the inverse, you should be looking for the points 2, 0 and 0, 4. So which one of those has those 2 points on it? Yeah, here it is, 0, 4 and 2, 0. Do any of the others have that? No. This one has got one of them. This one's got neither of them. This has got neither of them. So actually that's it. Okay. So I think we're going to say we'll start out next class and do the rest. I think there's 10. There might be a little less. And then we'll do our quiz. And you'll be able to use whatever notes you just took on this package. You'll be able to use them on the quiz. Okay?